Hello students, in the previous chapter we had discussed about the heating effect of the electric current. Now in this chapter we had to discuss the magnetic effect of the electric current. Now to know the basic of this effect, first of all we'll discuss about the Oersted experiment. So Oersted experiment, see this, say its circuit. AB is the conductor, AB is the conductor connected with a cell and key, you can say. So when current flows and when current flows A to B, we see there is a deflection in the compass, magnetic compass, which is placed just below the conductor, current carrying conductor. So to confirm that this deflection in the galvanometer is only due to the flow of the current. If we reverse the direction of the current, now it means, suppose it was plus, now make it negative. Okay, negative and positive. So in this another arrangement, if the current flowing from positive to negative, so suppose the current is flowing from B to A, we see the deflection is now in opposite direction. Initially it was in a particular direction and the direction is now totally reversed. So it confirms that this deflection is only due to the flow of the current, and the deflection in the magnetic compass is only possible when this current is producing the magnetic field, because the compass will deflect only in presence of the magnetic field and due to the magnetic force. So Oersted experiment shows that the current carrying conductor, its conclusion, current carrying conductor produces magnetic field around it. Okay, around it. It means electric current can produce the magnetic field. Okay, it was the conclusion of the Oersted experiment. Now we know very well what is the magnet and what is the magnetic field. Let me explain again. Suppose it is a magnet, I am taking a bar magnet. So magnetic field is that field around this magnet in which if any other charged particle or any other magnet brought, in that case this magnet will exert a force on that. Okay, it means, suppose it is north pole, so another magnet is suppose north and south, so north will repel to each other. So it means this is the field or this is the space around a magnet in which if any other charged particle or magnetic material comes, in that case it will experience a force acting on it. So this is the magnetic field, and magnetic field cannot be seen by the naked eyes. It can be shown only by the magnetic lines of force. So magnetic lines of force, you should know what does it mean. Magnetic lines of force means, suppose it is a magnet, and if you take a magnetic compass, it will deflect in a particular direction. Okay, it will deflect in a particular direction. Now put a mark by the pencil here and keep the magnetic compass again just in forward direction of this dot. Then again you will find the direction in the magnetic compass. Arrow will show the direction. So in this way you will find again and again some particular direction, and you will find that if you join all the points, then you will find a pattern of the lines. This pattern of lines, which are the imaginary, are known as the magnetic lines of force. Actually, magnetic lines of force are the imaginary lines which is drawn around a magnet. Okay, it shows the magnetic field. So there are few properties of the magnetic field lines. First, it starts from always north and enters into the south, and then again inside the south pole it enters and come out from the north. So it it makes a closed loop. It makes a closed loop always like this. Okay, always a closed loop, north to south and south to north, and then north to south. So it makes a closed loop. Clear? And the two magnetic lines never intersect to each other. Suppose this is the first line and this is the second magnetic lines of force. So two magnetic lines of force never intersect to each other. You should know why it is so, because at the point of intersection there will be two directions of the magnetic force. Okay, this is the force on this line and this is the force on this line. So there will be two lines, there will be two force at the same point, at the point of intersection, which is impossible. So two magnetic lines of force never intersect to each other. One more property is that if the number of lines is more at a point, at a place, it means the magnetic field is strong there. If the lines are very far, very less lines, it means the magnetic field is weak in that region. So number of magnetic lines indicates about the strength of the magnetic field. Okay, so these are the basic properties of the magnetic lines of force. Now we should also know what are the fields, which type of field we can see in different cases. Suppose a wire is straight. Suppose a wire is straight. So what is the direction of the current and what is the pattern of the magnetic field? Actually, it is a simple experiment you can do here. Suppose take a card sheet. Take a card sheet like this. Okay, and when current flows through this wire, and you can say iron springs, iron powder is spread over this hardboard, and if you jerk that, in that case it will spread over the hardboard, and the pattern you will find it is like this. Okay, all magnetic flings will get this type of pattern. It shows the magnetic field. So magnetic field, it is always circular, always circular. Suppose this is the current of I, so you'll get the direction of the current like this. Okay, and it will follow a specific rule. It will follow a specific rule. So you should know what is that specific rule. That rule is known as the very important rule. For exam point of view, it is the right hand thumb rule. Okay, this is the rule to know the direction of the magnetic field if the direction of the current is known. Okay, according to this rule, it is the right hand. Take your right hand in one direction. Suppose this is the direction right hand. So keep the thumb in the direction of the current. Suppose this is the direction of current. Okay, so keep the thumb in the direction of current and the direction of grasping. Okay, these fingers are moving like this, na? So this direction is the direction of the current. Okay, from here to here. Okay, this is the direction of the current. This is the direction of magnetic field. So keep the thumb in the direction of current, and the direction of current will show the direction of the fingers. Okay, so this is known as the right hand thumb rule. Okay, suppose this is the direction of current, so direction of magnetic field is like this. Okay, as I shown by my fingers. So this is the right hand thumb rule. This is the direction of magnetic field. So this is the magnetic field pattern due to the single current carrying wire. If you take a magnetic circular loop, in that case, see, suppose this is a sheet and a circular coil is given like this. And if the current passes through this loop, okay, like this. Now what will be the direction of the current? Okay, what will be the direction of or what will be the pattern of the magnetic field. So about the every wire, around every wire, this is the direction of current, like this. Okay, like this, like this, like this. It is always in circular, concentric circles, you can say. It is concentric circles. And the direction, how will decide the direction? This is the direction current, this is the direction of current, this is the direction of current. So here in upward direction, so direction of current, this is the direction of current. Okay, this is the direction of current. And here, what is the direction of current? This is just opposite. It is like this. Okay, this is the direction, direction of the magnetic field. So this is the direction of magnetic field here, and this is the direction of magnetic field here, due to the direction of current. So, and in between the two, because the directions of magnetic fields due to the both points is different, so you will get almost a straight line, almost magnetic lines straight here in between. Clear? So this is the pattern of the magnetic field due to a current through a circular loop. Okay, so you can show the directions of the magnetic field if you follow the right hand thumb rule. Now another topic is the magnetic field due to a current in a solenoid. First of all, you should know what is the solenoid. Solenoid means it is, first I am writing the definition, a coil of many circular turns of insulated copper wire wrapped closely in the shape of a cylinder is called solenoid. Okay, solenoid means, suppose any insulator, suppose this is an insulator and the wires are wounded over it, number of turns, copper turns, because copper is a good conductor. So copper wire, insulated copper wire, so it means the two turns should never touch to each other. So this is known as the solenoid. And when current flows, then magnetic field is produced. Just see, suppose this is a wire I am showing here. Suppose this is a small, this is a insulator, or so number of wires like this. Okay, like this. Okay, and when current flows through it, it shows all the property of the magnetic field. Okay, it shows all the properties of the magnetic field. So solenoid behaves as a magnet, and it shows all the properties of the magnet. That is, it has south pole, it has north pole. Okay, everything you can see here. Now you should also know which end is north pole and which end is the south pole. Okay, there is a simple rule, you should follow it. That is the clockwise or anti-clockwise rule. You can see here, if the direction of current, so suppose here the direction is like this is the direction. If the direction of current is like this, that is the clockwise direction, then this pole is the south pole. Okay, this pole is the south pole. In this example, here the pole is the south, this is the south pole. Okay, and if the direction of the current is anti-clockwise direction, then it is north pole. It is the north pole. So remember, so clockwise it is the south, and anti-clock it is the north. It is the north. So here it is the north and it is the south. It is the south, north, and in the figure it is the south and it is the north pole. So this is the solenoid, and we can distinguish the poles because it has all the properties of the magnet. Thank you, friends. In next video we'll discuss some questions, block questions, and the next topic of this chapter. Thank you.